4.7, problem 7. So we have it says storage rectangular, yes, rectangular storage container. Without a lid, has to have a volume of 10 cubic meters. The length of its base is twice the width. So if this is x, this is twice x. Material for the base, it will cost $15 per square meter. So this is 15 per square meter. Material for the sides costs $9 per square meter. So for the sides, 9 per square meter. Yep. Find the cost in dollars of materials for the least expensive such container. Okay. So of course the height is denoted by something. So I know that the volume of this rectangular box, if you want, container, is the area of the base times the height. Area of the base is 2x times x, which will be 2x squared times the height. And I know that this has to be 10. Of course, this will help me eliminate one of the variables. I will eliminate h dividing the 10 by 2 x squared, and I have 5 over x squared. Then I go back to the cost. So cost function of x will be the base, which is 2x squared, multiplied by its cost, plus twice this area, which is 2x multiplied by height, twice 2x multiplied by height, and multiplied by the cost per square meter. And then plus this area on the side, but it's also, oh, I meant plus. Also 2 multiplied by x times h. H is 5 divided by x squared, and also multiplied by the price per square meter, which is 9. I have to rearrange this function a little bit and clean it up. So I get a 30x squared plus, I will simplify this. So 4 times, so this is 10, 18, 180 divided by x. Correct me at any point in time. And this is plus 90 divided by x. So I'm assuming you got the function as 30x squared plus 270 divided by x. Was this your cost function?
I didn't actually build a cost function. I tried finding the area first and then computing the cost at the end.
It's a little bit more difficult because you have two different prices per square meter.
I split like the area into, you know, the two different parts, one for the $9.
That's fine, and then you added them. Okay, that's fine too.
I still couldn't get the right answer though.
Okay, so let's take a look. So 60x minus 270 over x squared, and I set this equal to 0, and I have to find the least common denominator, which is x squared. The top is x to the third. 60x to the third minus 270 equals 0, and only the top can be 0. So I get that x cubed equals 270 over 60. Let's see what this is. Simplify by 3, and I get 9. So x is basically the cube root of 4.5. So now they want round your answer to the nearest cent. Okay, fine. Find the cost in dollars of materials for the least expensive. So remember, this is not enough. I saw in your work, in your written work, you said this gives the minimum. Please, I don't want to subtract any points, deduct any points. So please, this is not enough. I have to show that that is the case. So 0 here, the cube root of 4.5, this is the cost, the rate of change, and this is the actual cost, this is 0. And I have to study the sign of this expression, which is the derivative. So the denominator doesn't have any effect, but if I put 0 in here, I get negative. And if I put 100 here and I cube it and multiply by 60 and subtract 270, I will definitely get a positive number. So this is definitely a situation for a minimum, absolute or local. So now I can determine this. So let's see how we determine that. So this is the function, and I have to plug that in. So C of the cube root of 4.5. It's 30 times the cube root of 4.5 squared plus 270 divided by the cube root of 4.5. It was a very good problem. So my calculator, here it is. So I have 30 multiplied by, I like 4.5 to the power 2 over 3. But that's me. You don't have to do that if you have a different method. It's fine. So plus 270 divided by 4.5 to power 1/3. So I got 245.31, and this is cost, so we are talking about dollars. And it says again near a cent, 245.31. Is that okay?
It might be, I don't know the actual correct answer that WebAssign wanted, but it's different than the answer I got, so that's that's already better.
Well, can you enter it then to check?
Yeah, I got like 252.88.
No, can you enter this one?
Oh, let me try.
And anyone else would like to ask anything, any questions?
How did you know what to add and what to multiply for the cost equation that you did up top? To see about.
So we want to go back to the cost function?
Yes. How did you know what to add and what to multiply?
So if I want to determine the cost of this piece, which has a pair in the back, I have two. That's not the one. This is the one. I have two because there are two. I have base times height, which is 2x, times the height, which is 5x squared, times the price per square meter, times 9. This is the cost of this front piece and the back piece. There are two. This is the area, and this is the cost per square meter. Is that better?
Yeah.
Now for the base right here, I have base times height, or length times width, which is 2x times x, which is 2x squared, multiplied by the price per square meter, which is this. And finally I reach the sides, this side and this side. They are two the same. Base times height is the area, x times the height, which is 5x squared, multiplied by the cost for the sides. All sides have the same cost of $9 per square meter.
Thank you.
So basically the cost equals the area times price plus another area times price and plus another area times price, because there are three different situations. These two, one situation, these two, another situation, and the base, the third one. So this is the area of the base times the price of the base plus the area of the side, this one, the long ones, times the price, corresponding price, times plus the area of the sides, these two, multiplied by their price. Is that better?
Yes, thank you.
Thank you. Anything else you would like to ask? Other problems, other questions from anything, from anywhere?
Yeah,
Yes, please. I'm ready.
It was 44 from the homework.
Which section?
It was section 4.7, number 44.
Okay, so let's take a look. Mark, was that okay? Do you have anything else?
Of course, it looks like that is the correct answer. That's good for me for now. I'll have to go try to rebuild it myself and knock it out for myself.
Okay, very good.
Thanks for the help.
Anytime. Okay, let me share my screen. So you see what I'm doing. It's just that my system, I think it's a little slow. I'm just trying to get to 4.7. I did not write solutions for tonight yet, so that's why I don't have them. Oh, okay. So, so we have a piece of wire that is 10 meters long. Very good. And we're cutting, sorry guys. Okay, so one piece is bent into a square and the other one into a circle. So we have a square, I will stop sharing in a moment, and a circle. Okay. How should the wire be cut so that the total area enclosed is a maximum or a minimum? Okay, perfect. Very good. So, I don't know where the wire, I'm just checking my video. Okay, so I don't know where the wire is going to be cut. I'm going to say here. So I'm going to say that this length is X and then this one is Y, which means this X is bent into a square. So this is X over 4, this is X over 4, this is X over 4, and of course this is X over 4. And this is the circumference of the circle, which is Y. So the circumference of the circle is 2 pi times R. R being the radius of the circle. So now the problem is asking us to find the total area of these two. So I'm going to call this A1, this is A1, and this is A2. And they're asking us how should we cut the wire anywhere so that we can get a maximum area and also a minimum area. Okay. So now we have to build these areas. We have to build this function, and then the rest should not be difficult. So, okay. What is A1 equal to? A1 is base times height, or it's a square, so it's X over 4 everything squared, or X squared over 16. What is A2 equal to? Well, it's pi R squared, and I have to solve this for R, right? So R equals Y over 2 pi. I don't like Y because I want to have only X everywhere. No, I don't want two variables, but that's easy because I know that X plus Y equals 10, so then Y will be negative X plus 10. So here is my radius, SY, which is negative X plus 10, everything divided by 2 pi. So this becomes pi multiplied by the square of the radius, negative X plus 10 over 2 pi, or pi negative X plus 10 squared over 4 pi squared. And I will simplify one of those. So I simplified each area as much as I possibly could, so I have 4 pi in the denominator. And now I have a function for the total area. So let's see how we, any questions so far? Is everything okay? I should have asked, sorry. Is everything okay so far?
Yes.
Questions, anyone? Thank you, Gia. Okay, so let's take a look. I'm on page 3. So then the total area now is x squared over 16 and plus this, negative x plus 10, everything squared divided by 4 pi. And now I can confidently say it's a function of x. So from this moment on, it's kind of done, but we still have work to do. So a prime of x, I'm checking my video, let me stop.